Hello students, we are meeting for our last lecture of the first chapter, that is manufacture of basic chemicals. Under that we have seen manufacture of ammonia, sulfuric acid, and we have finished the industrial discussion of the industrial process of manufacture of nitric acid. Under that we were discussing physico-chemical principles, especially for Ostwald's process. And as we know, the manufacture of nitric acid is carried out in three steps. That is, first step is oxidation of ammonia to nitric oxide, then oxide to NO2, and NO2 absorption of NO2 in water to form nitric acid. We have to discuss here physicochemical process principles for all the three reactions. Under that, in the last lecture, we have started the principles involved in oxidation of ammonia to nitric oxide, uh, and the reaction is like this. Here there is a higher supply of oxygen is required, and as the reaction is exothermic, low temperature is favorable, since the reaction is exothermic. But at low temperature, again, rate of reaction is slow, so optimum temperature is about 750 degrees Celsius is kept when pressure is 6.8 atmosphere. At higher temperature, there is a tendency of ammonia to get oxidized to nitrogen and decomposition of nitrogen dioxide, NO2. Thus efficiency of the process is decreased. The catalyst is only initially electrically heated to about 800 degrees Celsius, and then reaction continues on its own, maintaining that temperature. So that is the effect of temperature. After that, we were discussing effect of pressure. The forward reaction proceeds with little increase in volume, as you can see in the reaction. That is, on the reactant side there are 9 volumes, on product side there are 10 volumes, so volume is increasing. uh, so if we increase the pressure, equilibrium shift to left and decrease the yield. That is the expected according to Le Chatelier's principle. But there is some advantage of increasing pressure also. That, what is that advantage? If we increase the pressure, the space velocity. What is space velocity? Velocity of living gas is corrected to normal temperature and pressure, that is NTP conditions, which passes over 1 cubic foot per of the catalyst per second. Means it is a rate of gas flow through the catalyst at normal temperature and pressure condition. So that velocity increases, and hence larger volume of gas is converted by the same volume of catalyst. Means it is a maximum, you can say, use of catalyst if we increase the pressure slightly, not too much, because too much increase in pressure will start the backward reaction. Hence the larger volume of gas is converted by same volume of catalyst. Thus a small proportion of catalyst is sufficient. Okay, so for the other reactions, increase of pressure shift the equilibrium to right. Okay, hence larger amount of nitric acid is formed at higher pressure. The pressure applied in practice is 6.8 atmosphere. Okay, so up till now, up till this point, we have discussed in last lecture. We'll continue our discussion and continue the third physico-chemical principle is effect of catalyst. So you know, here we are using platinum rhodium catalyst. So what is the role of catalyst here? As we know, both the reactants are gaseous, so there should be some surface or some favorable environment where these gaseous molecules will come in contact. That is the 4 molecules of ammonia and 5 molecules of oxygen. So this, the probability of their interaction in gaseous state is very less. Therefore they are made to absorb on the catalyst surface where the probability of their interaction will be maximum and you will get the maximum output. So that is the use of catalyst. So here in this reaction, it is found that when catalyst is taken in the form of gauze means wire, okay, it is more effective. A multi-layered catalyst made up of 10% rhodium and 90% platinum is taken in the form of 80 mesh gauze. Okay, that is this wire which is made up of, that is 0.003 inches in diameter, very thin wire. Okay, and that is interweaved wire forming the gauze. Okay, so the here the weight of gauze is 105, that is 105 ounces. This ounces is a British unit. Okay, it is a weighing unit which is critical. This weight is very critical. There are about 20 layers of this gauze, means such one layer of this weaving wire gauze is there, and one above one like this there are 20 gauze. 20 layers of this gauze are used as catalyst, and the conversion of ammonia by volume mixed with preheated air at 300 degrees Celsius takes place through this catalyst at the temperature of 750 degrees Celsius. Okay, are you getting the conversion of ammonia? Okay, so here preheated air is passed, which is at the temperature of 300 degrees Celsius, and catalyst temperature is 750 degrees Celsius. Then only this reaction will take place, and such catalyst, if it is used, the yield of nitric oxide, that is conversion of ammonia to nitric oxide, is 94 to 95%. Means this is, you can say, maximum amount of yield that one can get if platinum rhodium that is alloy catalyst is used in the multi-layered form. Okay, and so this is all about the effect of catalyst. Next physico-chemical principle is effect of proportion of gases, that is ammonia and air. So here excess of oxygen should be taken because some oxygen is also required to convert nitric oxide to nitrogen dioxide. Okay, so excess oxygen has to be taken, that one should understand. Generally mixture consists of 10% of ammonia and 90% air by volume. Okay, so excess of ammonia is very important as far as oxidation of ammonia to NO2 is concerned. If the proportion of ammonia is in the mixture exceeds 10%, means here there is one problem with this proportion also. Means if the 10% ammonia content by volume increases above 10%, then there is a danger of explosion, because see this gas ammonia mostly remains in gas state, and we are applying lot of pressure, okay, on the reaction mixture, that is 6.8 atmosphere. So if we increase the amount of ammonia, then becomes difficult to handle at such a high pressure. So it may cause the explosion. So here you have to take care that in that gaseous combination or proportion, ammonia should not increase or cross the limit of 10%. Similarly, many side reactions may occur that reduce the yield of nitrogen oxide, and more ammonia is wasted. Means if we are using excess quantity of ammonia than which is proposed, then not only there is a danger of explosion, but there is a possibility that any other unwanted undesired side reactions may take place. So this should be avoided. Okay, and that will reduce the yield of the desired product. So this should be avoided. So proportion of gases is very important in the case of this reaction. And last is rate of flow of gases. Now here, as I told you, uh, the proportion of gases uh, to get converted to product is very less. Okay, so first of all we're using catalyst. Second thing is rate of flow of gases, means the here reactant is gas, product is also gas. So the input gases and output gases should be, the flow should be controlled. Okay, so in the reactor all ammonia should get oxidized at once, otherwise second reaction between unused ammonia and nitric oxide produced in the main reaction may take place. So that is the problem. Okay, so incoming gases and outgoing gases, if they are not their flow is not controlled, then what happens? There is a chance that unreacted ammonia, okay, and the product, that is nitric oxide, may combine with each other and get converted to nitrogen gas. So that is going to reduce our yield. So therefore here, to avoid such unwanted reaction, so the gases should not remain in contact with the catalyst for a long time. Means ammonia is going to adsorb. Okay, whatever NO, that is nitric oxide, which is formed, that should leave. As soon as NO is formed, it should leave and it should be replaced by ammonia. But if the flow of gases is not controlled, then at a time there are chances that ammonia and NO may come in contact with each other on the surface of the catalyst, where such unwanted conversion of ammonia to nitrogen may take place. So the rate of flow of gases should be high. For rhodium platinum catalyst at 650 degrees Celsius, the best time of contact is 0.0014 seconds. Okay, so you can understand such a fraction of second, that you can say 1.4 millisecond, you can say. Okay, so 1.4 millisecond contact time should be there. Means considering this, for this much time only gases should be there. So considering this, you can design the flow of rate of flow of gases. So if the contact is longer, no doubt NO is going to decompose as nitrogen and oxygen. So rate of flow of gases is also very important factor here in this Ostwald's process, that is first step, that is conversion of ammonia to NO. Okay, now this completes the physico-chemical principles of the first step, that is oxidation of ammonia to nitric oxide. We'll see the physico-chemical principle for the second step, that is conversion of nitric oxide to NO2. Okay, so here the reaction is like this. Here again the product which is formed, NO, in the first step will again react with excess of oxygen to get converted to NO2. This reaction again is reversible. Okay, and the forward reaction is exothermic. You can see a lot of energy is evolved, and there is a decrease in volume when NO2 is formed. You can understand, on the reactant side there are 3 volume, whereas on the product side there are 2 volumes. So volume is decreasing, means pressure is to be increased. So according to Le-Chatelier principle, high pressure and low temperature is favorable here. Okay, because low temperature, why? Because reaction is exothermic. High pressure means volume is decreasing. So that these two are the favorable condition. This conversion of NO to NO2, means nitric oxide to NO2, takes place at 150 degrees Celsius. See, the reversible reaction is 600 degrees Celsius. So you should not let the reaction temperature rise. Okay, reaction temperature should be maintained at 150 degrees Celsius and 6.8 atmospheric. So since this reaction is slow, more contact time is necessary for oxidation. That is also very important thing. So it is unlike to your first step, that is in first step there should be 1.4 millisecond contact time. Then only your yield will be maximum. But here the reaction is slow, so contact time should be more. So that care you have to take. So here also rate of flow of gases is important, and depending on that you can increase the contact time. So these are the only favorable conditions that will bring about the maximum yield in the second step. Now we'll go to the third step, that is absorption of nitrogen oxide, that is NO2, in water. Okay, so here when it absorbed in water, the reaction takes place like this, that is NO2 get dissolved in water to form nitric acid. Okay, absorption, it is a slow process. Okay, so water is in the liquid form and NO2 is in the gaseous form. So when you bubble this gas in water, you have to let that gas get absorbed in water. So this is a slow process. This absorption will take place slowly. So more space is required. Okay, absorption of NO2 by water under controlled process give nitric acid, that you can see here. The forward reaction is exothermic. So here also a lot of energy is evolved. So this is an exothermic reaction, and hence the rate of reaction can be increased by cooling the gases to cooling to the 40 to 50 degree Celsius. Now you know first step is carried out at 750 degree Celsius. Second step, which is just discussed above, is carried out at 150 degree Celsius. So the product which is of the second step is at the 150 degree Celsius. So here if you cool the gases to 40 to 50 degree Celsius, the yield is going to increase, because here the reaction is exothermic. So if by cooling, if you absorb that energy, backward reaction will not be there, and therefore you can reduce the temperature. Okay, so and this is achieved by employing counter current graded strength of acid for absorption. Okay, so the nitric acid produced in this Ostwald process is 61 to 65% in strength, means it is not highly concentrated. Okay, so still there is a 35 to 40% water is there. Okay, still the conversion is more than 90%. So that is the useful or beneficial part of the process. Now further you can concentrate just by carrying out the concentration process, that is using sulfuric acid or using magnesium nitrate. So after discussion of the physico-chemical principles of the all the three steps, we have come to the conclusion what are the favorable conditions for better yield of nitric acid. And the favorable conditions are like this: the temperature requirement is 750 degrees Celsius for first step, that is oxidation of ammonia to NO. Then in second step, conversion of NO to NO2, the temperature should be 150 degrees Celsius. Here throughout the process the pressure should be 6.8 atmosphere. The catalyst in the you can say 80 mesh gauze form and made up of 10% rhodium and 90% platinum. So this catalyst is optimum forms the optimum condition. And the very important proportion of gases, that is ammonia should be 10% and oxygen should be excess, that is 90%. You cannot increase ammonia volume, because that is going to lead the explosion as well as unwanted reaction. So these conditions if you may maintain, then you will get a good amount of yield of nitric acid by Ostwald process. So this is the favorable condition. Now this completes our manufacture of nitric acid and its physico-chemical principle. Now we'll come to the last point, that is uses of nitric acid. What are the various uses of nitric acid? Very first use you can see, that is in the explosives. Okay, so here before discussing each separately, I would like to put it in the diagrammatic form like this. So you can see the various or varied spectrum of applications of nitric acid, and that makes the very important basic chemical that one should know how it is manufactured on industrial scale. So all of you know, most of the explosives which are used, they are nitro derivatives of the organic compound. So whenever nitro derivative comes in mind, you have to go for nitration reaction. And what is nitration reaction? Nitration reaction is carried out by using nitronium intermediate, which is formed by nitrating mixture, that is a mixture of nitric acid and sulfuric acid. So very important chemical for nitration is nitric acid. So nitration of most of the organic molecule converted to the explosive. For example, TNT. Okay, what is TNT? Full form is trinitrotoluene. All of you know toluene. When methyl group is connected to benzene, that is a toluene. So this toluene is made to undergo nitration process. So excessive nitration, that is at both ortho and para position, that is 2,4,6 trinitrotoluene. Okay, so 3 times nitration of one molecule gives you TNT, trinitrotoluene, which is very important explosive. Another is you must have heard about gelatin candle, which is made up of you can say cellulose or glycerin. So if you make it nitroglycerin, same thing, nitration is carried out by nitric acid. Then gun cotton or ammonal, all these are nitro explosives which are very important. Its applications are very important, but how to get manufactured these explosives, and the inevitable step is nitration, which is carried out by nitric acid. Then another very important application of nitric acid is fertilizers. Okay, so fertilizers cannot be made without nitric acid. So the reason is all of you know, the fertilizers are the source of nutrients for the plant, and major nutrients are NPK, N for nitrogen, P for phosphorus, K for potassium, that all of you know. So in the different proportion of NPK as per requirement of the particular crop or plant, company manufacture the different fertilizers, but you cannot skip the contribution of N, that is nitrogen. So in this fertilizer, most of the nitrated or ammoniated products are compounds are used, which can be manufactured only by using nitric acid. For example, calcium nitrate or ammonium nitrate. So these can be used as a fertilizer. They are a you can say good source of nitrogen for plants. Then nitrate salts such as calcium nitrate, silver nitrate or ammonium nitrate, they are very important for various kind of reaction. So the nitration of these metals can be achieved by nitric acid. Also this nitric acid is used for dyes. Okay, then perfumes, then drugs. So these you can say their manufacture involves the use of nitric acid. Then just now we have discussed the cell manufacture of sulfuric acid by contact process, but one more old method was there, that is lead chamber. So wherever the old plants are there, that is using lead chamber method, manufacture of sulfuric acid is involved, there you need the nitric acid. So that is also very important application of nitric acid. Then it is this nitric acid is used in purification process, or you can say extraction, sometimes extraction, sometimes purification of silver, gold and platinum. So these are very valuable metals. Okay, so extraction of these metal is very important, or their purification is very important, which can be achieved by using nitric acid. Okay, so whenever any metal is given along with the impurities, it is treated with nitric acid. So this they form the nitrates, and depending on their solubility they separate it. And once you get separated, again you can decompose it and you get the original metal. So separation or purification from the contaminant can be achieved by using nitric acid. Then next is nitric acid is used in etching designs on copper, brass, bronze ware. Means here nitric acid, when reacts with this copper, brass or bronze metals or metal alloys, it get dissolved. So it, you can in a way it is a etching process, so you get a kind of design on the surface of that object. Okay, so for that etching process nitric acid is used. Okay, it is also very important, uh, it it is a participant of making very important solvent. See, when you go in the lab, you are for inorganic qualitative analysis. Okay, you must know that. You first, when you go for after dry test, when you go for making original solution OS, first you try it with water, whether it is soluble in water. Okay, if it is not, then go for dilute hydrochloric acid. If it is not, then go for concentrated hydrochloric acid. If it is not, then go for concentrated other acids. And at the end you go for, if at all that salt is not soluble in any kind of solvent, then at the end the final very you can say drastic solvent with high potential to dissolve any metal complex or any metal, that is aqua regia. Okay, so what is this aqua regia? Aqua regia is a mixture of nitric acid and hydrochloric acid. Okay, uh, so this aqua regia is very important. Okay, so aqua regia, one of the part is nitric acid. So this dissolution of most of the noble elements like gold, or you can say silver, these noble elements can be dissolved in aqua regia. Okay, then there are other noble elements also which can be dissolved, but here mostly aqua regia is used for dissolution of the metals. Then it is very large, on large scale it is used in laboratory for laboratory reagent. One more application is more in many oxidation you can say process, oxidation step. So many times oxidation is carried out using nitric acid. So all these are applications are mentioned, you can see here, that is explosives, there are synthetic uses, that is paints in making nitrates, making fertilizers, or in purification of metals, or making aqua regia, or making or extraction, or making coal tar products, or you can use it in lead chamber process for manufacture of sulfuric acid, or you can use it for etching process, etching of copper, bronze or brass. So there is a, you can say this diagram itself indicate the wide spectrum of applications of nitric acid. So here this completes our first chapter, that is manufacture of basic chemicals. Okay, so in this chapter we have discussed the manufacture of ammonia, manufacture of sulfuric acid and manufacture of nitric acid, and we have discussed their physicochemical principles, their applications, all, and their how it is manufactured on industrial scale. So this chapter, I think you will find it very comfortable or easy. If still you have any problem, you can ask me, you can comment on our Google Classroom as and when you want, or and then I will get the your queries, and in between, as and when possible, we'll arrange one live lecture on Google Meet. Then we'll discuss all your doubts and difficulties. So as far as exam is concerned, I will advise you, you can use this Manali book, because at the end of the chapter there are a number of questions are given which were asked in earlier exams, so you can prepare accordingly. Again, I am repeating here, I am not advertising this Manali publication, just for your use. Or you can go to the university website and download old question paper and try to solve all the questions. If you have any problem, you can ask me at any time. You can comment on or reply, or your place your questions on the platform of Google Classroom, so we can discuss at that time also. Okay, so I will let you know when I'm going to conduct the live lecture. So for time being, we'll stop here. Thank you.